Okay, welcome to this problem involving a circle inscribed in a right-angled triangle. Okay, not much information is given about the dimensions or anything, but what we've got to do is find the area of the circle as a percentage of the area of the triangle. Now, I first look at a problem like this and determine whether the diagram is roughly drawn correctly, and if it is, what do I expect the answer to be visually? And I'm looking at that thinking the circle is about half the area of the triangle, maybe a bit less. Now you should have a go at this problem first. Just pause the video, have a go, and come back to it when you're ready to see one solution that I'm going to offer. Okay, and I'm now going to start working through the problem now. So let's put in some extra information first of all. Now I know from circle theorems that a tangent meets a radius at 90 degrees. So that's a 90-degree angle. There's another one in there, and I can quickly see that there'll be one in there. Now that's helpful because it means that that's 90 degrees. So I have 270 degrees making up my 9x. So my 4x and 5x must total 270, and that therefore tells me that x is 30 degrees. Okay, and that's useful because I now have some more information on this kite that's formed here, because that's 120 degrees. And this angle down here is going to be 60 degrees, okay? Because the remaining two angles in the kite are also right angles here and here. Okay, now that's going to be very useful, along with the fact that this length here is r, and this length here is r, because they're all radiuses of the same circle. I also know that this section here is of length r, and this part here is a lot more. And I also know that this is 30 degrees because the whole thing is a right-angled triangle. And if I have a 60 over here and a 90 up here, that's also 30 as well. So I've already been able to add quite a lot of information in. Now what I'm going to do is work with this kite here. And I'm going to split it straight down the middle and make a triangle or two equal triangles out of it by doing that. Okay, and I now can see that I have an angle of 30 in here. Okay, so that's 30 degrees, just that half of it there by symmetry. And I'm going to use the information I have in this triangle to work out the length of this bit here, between here and this corner here. So that line there I'm going to call of length A. Okay, now using right-angled triangle trigonometry, I know that 30 degrees has a sine of a half. Okay, that's one of the well-known trig ratios. The sine of 30 degrees is a half, okay, and the tan of 30 degrees is 1 over root 3. Okay, so what I'm going to do now is I'm going to say that r over a, that's opposite over adjacent, okay, so r over a equals the tan of 30. And the tan of 30 is 1 over root 3. Okay, there's a separate video explaining how to get the exact values of sine, cos and tan of 30 and 60 and 45 degrees if you want to look that up. Okay, so we know that that is a fact, and from that I can work out that if I multiply both sides by a and divide by root 3, I can say that that the length A is actually the same as r times root 3, or r root 3. Okay, now that's the first thing I'm going to be making use of. So what I'm actually saying is that the total length across this side, so if I just maybe put an arrow across there to show the length of this side of the triangle here, okay, the length of that line is r plus r root 3, okay, because we just worked out what A is. So r plus r root 3, which can also be written as r brackets 1 plus root 3. Okay, so that's going to be useful later on in the problem. Now, I can also use the same thing again, really, because I've got an angle of 30 degrees in a right angled triangle with an opposite of r1 plus root 3. So I'm now going to use that to find this length here, b. I'm just going to call this length here b. Okay, and I can say that r1 plus root 3, that's the opposite, okay, divided by the adjacent, which is b, is also the tan of 30, okay. So I'm using the same kind of reasoning as I had before. Tan 30, which we know to be tan 30, which we know to be root 1 over root 3. Okay, if you cross multiply that again, that tells you that b is equal to r times root 3, so or root r times root 3 times 1 plus root 3. Okay, which is equal to r times root 3 plus 3. Now, what we now have is a right-angled triangle where we know this length here and the perpendicular height. But you've got to imagine that this triangle is tipped over or rotated so that b is the base and this length here is the height. So using a simple formula, half base times height, I can work out the area of the triangle in terms of r. Okay, so I'll come over here now. So a half of base, right, times height, and remember the height is a plus r. Okay, that's the height of the triangle. Okay, is equal to a half of the base, which is r root 3 plus 3. Okay, so it's a half r root 3 plus 3. Okay, times the height, which is 1 plus root 3. Okay, I'll just put another r in there as well. So times r times 1 plus root 3. Okay, now if I rearrange that slightly, that's a half r squared. And then I've got to multiply out the two brackets. Okay, so I'm going to have root 3 times 1, which is root 3. That's the first. The outer is going to be root 3 times root 3, which is 3. The inner is going to be 3 times 1, which is also 3. And the last term is going to be 3 root 3. Okay. Now, if I just simplify that a little bit further, I get a half r squared times, and it's going to be 4 root 3 plus 6, or 6 plus 4 root 3. And that simplifies a little bit more because of the half, so I can write that as r squared times 3 plus 2 root 3. So that's the area of the right-angled triangle. And we know what the area of the circle is. It's just pi r squared. So the circle, I better put some description here. So if I do it here, circle, okay, over triangle, because I want to find a percentage, you see. So I need the fraction first of all. The circle over the triangle, in terms of area, is going to be the pi r squared divided by this thing I've just worked out. Okay, which is that. And clearly the r squareds cancel to give me pi over 3 plus 2 root 3. Okay, now if I put that on the calculator, that comes to well, several decimal places, but that gives me 0.4860, and then it goes on with several decimals, and I'm required to give it as a percentage. So that's simply 48.6% to 3 significant figures. So it is indeed just under half the area of the triangle. And that is the answer to the problem. Okay, so we kind of knew that the r would have to cancel out somewhere, because it wouldn't matter how large or small r was, it wouldn't change the problem, because the shapes would be similar. If we just enlarged them, they would enlarge at the same rate, the circle and the triangle, in order to keep the circle inside the triangle as it was. Okay, so it's a very algebraic sort of problem, and there it is. Okay, take care.